Hi everyone. In part 4 of our class, we're going to estimate population parameters, which could be something like a population mean, a population standard deviation, a population variance, or as we'll see, a population proportion or probability. To estimate these population parameters, we could use a point estimate, which is a single value, or an interval estimate. That's where confidence intervals come in. So in part 4, and later in part 5 of our class, we're going to be dealing with inferential statistics, which is the magical, applied, and controversial part of our class. This is the part where pure mathematicians get very nervous, but it's what you see a lot of in real life. This is what a politician with a pollster would really care about. So back in lesson 1, we talked about the overall scheme of the class. So where are we in this class? Well, first of all, we talked about designing an experiment, and in particular, defining a population of interest. For example, do you care about all adult Americans in the end? Do you care about all registered voters in California because you're doing a political poll? What is the population of interest of size big N? And then, step 2, collecting data. Now, I didn't have you go out and grab random students. That would be inappropriate, especially nowadays. But we talked about schemes such as simple random sampling, systematic sampling. We talked about random number generation, which could help you figure out who to poll, and other methods. In part 3, describing data, and that's descriptive statistics. So from a population, let's say you draw a sample. Okay, a sample of size little n, maybe 1,000 people for a political poll, okay? Or maybe a scientific study, such as maybe we're gathering a sample to see what their situation is with antibodies for coronavirus. Or it could be in a factory. We're testing products for quality control. These could be pills, for example. But anyway, in this sample, we can get sample data, presumably quickly. That's the idea behind drawing a sample, instead of doing an outright census for the population. So within the sample, we might be able to ask voters, are you for a candidate or against a candidate? We can ask, what's your weight? That might be a bit rude, but we can ask, what's your weight? Or what's your age? Or, more politely, we can grab a pill off the assembly line and take its weight or mass. But we can get data for our sample, and we can describe this data by using things like histograms, dot plots, pie charts, things like that. And that was what we did early on in the course. Now, we're going to interpret the data based on the sample. So based on the sample data of size little n, what can we try to infer about the overall population of size big N? So if we take a random sample of 1,000 registered voters in California, and we want to ask them, do you have a favorable or unfavorable view of President Trump? Well, based on the sample, we can try to infer the actual population parameter of interest. What is the proportion of registered voters in California who have a favorable or maybe unfavorable opinion of President Trump? Bear in mind, there may be other categories, favorable, unfavorable, or maybe other or undecided. Although with President Trump, there don't seem to be too many people in the middle. Inferential statistics, the science of interpreting data. Very controversial, but very useful. What can a sample tell us about the population from which it is drawn? So that is going to be our key topic for the next several lessons.